Hey everyone, this is Athena X. In this video series, we're going to learn about enumerative combinatorics. Basically, that means counting. By the end of this series, we want to be able to answer interesting questions and riddles like the following. How many people do you have to put in a room in order to get at least 50% probability that at least 2 people in the room have the same birthday? How many ways can you put R balls in N bins? Both of those questions are surprisingly not easy, but we'll work our way up to them. Besides fun math challenges, combinatorics plays an important role in probability, graph theory, computational complexity, and other subjects which underlie a lot of modern science and technology. You may have also seen examples of combinatorics in card games like blackjack and poker. In general, combinatorics is about combining things, which means arranging, selecting, and counting. Enumerative combinatorics focuses on the counting. For now, let's start with a simple example. How many ways can I arrange a triangle, a circle, and an X? Well, I can do triangle, circle, X, triangle, X, circle, circle, triangle, X, circle, X, triangle, X, triangle, circle, and X, circle, triangle. Now there's 6 arrangements, and you can go through and check that each arrangement is unique and that I didn't leave any arrangements out. Now, instead of writing the shapes, I could just say shape 1 for triangle, 2 for circle, and 3 for X. Now I'm going to label each of these 6 arrangements of shapes with these new number labels. So we have 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and finally 3, 2, 1. Now instead of remembering all these objects, we can just deal with numbers. We don't have to remember triangles, circles, X's, birthdays, balls, and bins. We just use numbers. My examples will often deal with numbers, but remember they could represent anything. In other words, the number of ways to arrange any 3 objects is 6, regardless of what the objects are. Cool. So it turns out that the key to understanding combinatorics is to understand sets and set operations. In the next video, I'll go over some basics that you'll need for this series. But if you're interested in a complete and intuitive understanding of set operations and proofs, I'll link some good resources in the video description. I might also publish a sets video series in the future. If you already have a good understanding of sets and unions and intersections and operations like that, you can skip the next video. Until next time.